Thank you very much. I'm actually quite nervous because Imo, my lab student, she did a really great talk last time. And our first speaker today took bioethics with me. And he gave an absolutely brilliant talk as well, so I can only disappoint. That's my disclaimer right here. But 5 of you are going to walk away with a little present. So that's my only excuse for giving the talk today. I am very happy to field comments and questions as we go. 途中で質問、コメントぜひお願いします。I realize that we have different language proficiencies here. Some people are really very good at English, maybe less at Japanese. Some people are very good at Japanese, maybe less at English. I'm more of the first part, and I tend to speak too fast in English. 悪い癖で、英語を話すのはちょっと早口でいつもやるんですけれど。So I'll try to switch sometimes to Japanese. So let's have a bilingual environment. I know I should do 20 minutes, and I have a habit of speaking about, and chatting too long. So my time starts here. I estimate that I have about 200 minutes of materials. So let's just go ahead. Yes, sleeping bear, sleeping penguin. I'm going to talk, and this is really going to be a behavioral talk. Today was behavior 行動の話としては、俺は本当の行動科学者. So I'm really a behavioral scientist. And so I don't want to say too much about my background at Kyushu University because it only makes it more hazukashi if I fail. So behavioral science is really my home. That's what I've trained in, and that's also what I sort of always navigate back to. So 専門としては本当の行動解析という科学者なんですけれど。So I'm going to talk today about don't look, but of course you do. And so if you say don't look, this first thing you want to do is look. And so this kind of paradox of inhibition, which is very core to everything we know about human being. That's going to be my topic. So, 見ちゃダメと言ったら見たくなるというのを話。はい。So, I want to begin straight away with the beginning of humanity, at least according to the Bible, which we know to be a book of lies. But it has interesting lies, and it's a book of stories, if you want. So 物語の本としては、楽しく読めると思いますけれども、so Bible. They have this story about Adam and Eve. You might have heard of it. And you know that this is a story that has been advertised and marketed a lot from 100 years ago. This is, I hope you know, a wonderful sort of tribute to the talent of human being. And it was done by Michelangelo in the Sistine Chapel. And maybe this part looks very familiar. But right after you see Eve coming out of the rib of Adam, which is, of course, an extremely sexist interpretation that you get in the Bible. I told you it's the book of lies. But it does have interesting stories in it. And it is this story of don't eat the apple. Yeah. And, of course, that's the first thing that's going to happen after the boss tells you not to do this. Then they're going to do this. Here you can see another sexist interpretation because the snake is already drawn or painted as a female in this sort of work by Michelangelo. But, so in any case, as I said, it has been marketed a lot. This is a painting, it's actually a Flemish painting, and I'll do a little bit of self-introduction here. I am from Flanders, ベルギー人で、フランダーズ出身で、これはフランダーズの、絵として。And so this was painted in the 1600s, and it was actually a collaboration. And I really love it in the sense that it is a collaboration. And so you can see here, there was one painter who was very skilled at painting animals. That was Jan Breugel, the elder. And then you have here a painter who was very good at painting bodies, especially full-shaped bodies. And that was Peter Paul Rubens. But you have other paintings as well here. And I'm going to go straight away to our first quiz. First present to be got. And it will have to do something with vampire. So I want you to remember, if anything you remember, and it has absolutely nothing to do with my talk, please remember vampire. So that was the vampire talk. And vampire stands for visual art plus music plus poetry. That's the vamp. Visual art, music, poetry. At the I is for Itoshima, because I live in Itoshima. The R and the E is for event. The R I had to fill in because I wanted to have this acronym, so the vampires, I had to think of this R. And there are plenty of R's that you can think of. Revitalization. We were discussing with Raymond and other people recently that there's not enough happening in Fukuoka. And so we need nerd nights. We need more events at all kind of scales. Small scale, big scale, fun scale, whatever scale, we need more. And so I want to start something in Itoshima. Maybe I'll pull in Raymond as well as a collaborator. That's what what's that?
The last one.
So first of all, rebellion is easy, I guess. R as a rated R is restricted. Again, going against what is forbidden. Ribosomal is a sort of biological process that sort of goes lateral and creates networks. So that's why ribosomal. So I'm setting up this vampire, which is in a sense a art version of Nerd Nite. And I'm starting to look for, I'm planning to start this from next year. And yeah, I'll be looking for collaborators. Anyway, I've got vampires with me. Our first merchandise.
Whoa.
We have the logo beside this. Our merchandise will kick off today. So this is total promotion talk. But so the first question then is, who painted this?
This picture.
This. So we had Breugel and Rubens here, but who did this one? Anybody who says something has already a chance to get the prize. So I heard somebody different here. And so if I don't get a better answer, you will be the first winner.
Da Vinci.
Da Vinci. Raphael.
What's the time here?
I'm not giving any clues. That's cheating. That's minus there. Okay, we had Da Vinci, Raphael, somebody different, a minus, and? Yeah, I have to do twice now too easily. Somewhere English? Okay, come on. Okay, I don't have time. You win. Because that was totally coincident. So, of course, this was Rubens. So that means all of you have stylistic recognition 0. So I must say to the semi-researcher, the cicada researcher, he has so wonderful analysis kind of powers. I'm missing that in our audience today. Anyways, okay. So chapter 2, a don't look story. First we have actually a sort of a don't touch story from the Bible. This one is more of a don't look story. So Orpheus and Eurydice. And I hope you remember the story a little bit. And it is all about how Orpheus, who is this magical singer, was a human being, poet, he could sing so beautifully that the gods gave him an exception. So when his loved one died of a snake bite and had to go to Hades, he was given the exceptional opportunity to get her back at one condition. Don't look back. Yeah. And of course he did. So I'm not here going to psychologize about why he didn't look or didn't follow. So why did he look back? There are many different theories about that. I'm a phenomenologist. So first of all, I describe and analyze the behavior. I'm not an evolutionary psychologist who tell sort of fake stories about why that was the case. Anyway, vampire. Vampire. So who painted this? Who painted this? Come on. We had very humiliating responses before.
Ribbons.
See, we have one genius in the house. Good, excellent. This was Rubens. Of course it was. You could see from the style. And we can now, further on, I do have a couple of other Orpheus images. A very interesting one here from Oskar Kokoschka, who is like a more expressionist painter. And it's a very interesting way of reinterpreting the Orpheus and Eurydice myth. And that's, of course, what you see in these stories. And the fact that you have these don't look stories, those これじゃダメというような話はあちこちいつも出てくる。And we see them in ancient stories, but also in very modern stories. And so I think these myths, they really come back and they give structure to the stories. And if you talk to somebody like Claude Lévi-Strauss, you'd have to talk with the zombie of Claude Lévi-Strauss because he's been dead for a good while. But it is true that we have only a limited set of stories, and they do come back. And there is something basic human condition aspect about that. So we do well to look at those stories. And it's very interesting to see other evidence here points exactly to that. With Izanami Izanagi, we have exactly an Orpheus and Eurydice story. It's amazing. Good try. I do have a vampire moment here, but it is of a different question here. So I felt a little bit lazy, and I thought at this point I don't want to do this story about Izanami Izanagi. So anybody here can tell me in 1 minute the story of Izanami Izanagi? Willing to do that? Anybody willing to do that?
Raymond can.
Raymond, but he was looking at his watch. He says he's been doing this for 10 minutes already. He's still at the introduction.
I don't know. Izanami,
Izanami Izanagi.
Wow,
No takers?
From Kojiki.
Koji, yes, from the Kojiki, yes. There are two versions in Nihon Shoki mo aru desu keredo. Anybody willing? Anybody has the guts? Nihongo demo okay desu. Eh? What's that? So that's why I need somebody to tell this story. I don't want to do it.
But they're gods from understanding Japanese. They're gods.
That's true, exactly. They are really sort of.
40 more seconds. Keep going. I can't explain the story, but very similar to that kind of story.
Yeah, well, I'm going to leave it at that, and I'm going to give you the bag for excellence. Yes. So basically, Izanami Izanagi is very much a similar story. They did a lot of things that can be reinterpreted as plain sex to build islands and mountains and what's so on.
Is that
And
from Persona?
yes, exactly. So this is what happens later. So at some point, Izanami dies, and she has to go to the underworld. But Izanagi gets one chance to go get her. So the gods sort of leave open the door. They don't really clearly say whether they're going to get her back or not, but he gets a chance at a condition, and Izanami tells her, okay, I'll come back with you, but don't look. And of course he did. And when he did, he saw that she was a rotting corpse with 8 snakes in it. And so she got so angry that he looked at her, that he basically was chased out by her. And she said, I'm going to kill 1,000 people a day. I'm so mad. I'm going to kill 1,000 people a day. And Izanagi responded, well, if you're going to kill 1,000 people, I'm going to make 1,500 people a day. And so that's how we have life and death in humanity, thanks to Izanami and Izanagi. So great story. That was my introduction. And so now I'm going to start talking about you and me. And so when I talk about you and me, then as a behavioral analyst and cognitive scientist, I'm going to try to say general characteristics of people. And of course, there's a lot of variability among people, but I try to see what is common. I look for commonalities. And I do that in research, especially on thought and perception. And so I'm a cognitive scientist, very much behaviorally trained. I'm going to talk about this paper today. But I want to say a couple of words about the type of research I do. In some sense, my work is very similar to our previous speaker. And so I also belong to the Graduate School of Systems Life Sciences. That's why he had to take bioethics with me. I asked him, did you do well on my course? And he sort of said, yoroshiku onegaishimasu. But I don't know. So I do sort of more systems science, sort of biology-oriented research. I'm also a cognitive neuroscientist. I use tools like eye tracking, and I measure physiology, and that goes the biometrics, typical biometrics such as heart rate, also pupil dilation, things like the cold shiver, which we basically call sort of the sweat response. You can measure. And then you also have, of course, electrophysiology. You can measure from the head, the electroencephalography. I do that in collaboration with another researcher, so for brain waves. I used to do neurophysiology with animals like monkeys and rats, but stepped away from that. Anyway, so it's very sciencey. And this is one of my graduate students. He's always the guinea pig.
So that's what happens with graduate students.
Yes, that's why we need them to experiment on. They think they're in control. But anyways, so vampire move right here. So we use eye tracking as a very important tool for thought and perception. And again, I didn't want to tell this story, so anybody can tell me very quickly, why would you ever want to do eye tracking? What is that going to tell you in terms of, talking about behavioral science or cognitive science or whatnot? Why would you want to track the eyes?
So people is thinking.
You've got a bag already, so you got to. But it's too general as an answer anyways.
Direction.
You can understand.
Don't talk.
Your subconscious brain is focusing in on that maybe your conscious thoughts don't understand.
That's a very good point. And so I'm ready to give you the bag for that, but I want to sort of prod a little bit more. So exactly how does it do that? So what's that?
I don't know, like the biomechanics of it, but if you're, let's say you're a closet gay man, you come into a bar and you see a bunch of strippers over here from Tennessee.
Is it? Well, I'll take that. He's laughing already. Exactly. Yeah, that's it. That's what I wanted to say. Yes. So that zap of the eyes, is telling them, yes, exactly. That's it. You totally deserve a bag. Yes. Excellent. Thank you. Yes. But that's exactly the point. And so how we take visual information in, the point is that we don't take snapshots like we do with the iPhone. So our eyes are not cameras. And so we cannot take the whole scene in at once. And so we take in small portions, which means that what we see is really bit by bit. And what we see bit by bit does not necessarily correspond with what we are thinking about. And so what we're thinking about is an interpretation of that. So the two things tell different stories. And so basically with eye tracking, we see bit by bit what is being processed, and you can compare that, and that's basically subconscious but feeding into conscious. We can compare that with the semantics of what is being processed. そこは今日本語で説明するのちょっと難しいなんですけれどもmaybe I'll ask Nana to explain later if necessary. Yes. But so I want to talk about a project. So this is the type of data that you can have. So if you see, you can do analysis. If you look at a visual scene, you can draw literally sort of heat maps of what portions of the image are looked at more often. And so this just gives a probability distribution of what people look at. But you can also trace that more sequentially, like in what order, when are people looking at things. So we wanted to do a study on that. And it's going to be a don't look study. Very much a don't look study in two ways. And I'll just try to explain it in the best way possible, because it's just doing an academic presentation now. But I'll sort of explain the why and wherefore sort of on the go. So an eye movement task. So we already know moving your eyes is really something you need to do bit by bit. And we can train, so you can control where you move your eyes. And a little bit with the example, if you realize like, I'm not supposed to look at that, then you'll maybe look here, but your mind is, you know, where you shouldn't be. But so we can train ourselves to look someplace. In this task, we're going to have people sitting in front of the screen. We're tracking their eyes, and we're telling them, look, you know, specific points. We start the image with this fixation cross, as we call it, down at the screen, and we tell focus at the fixation screen. So first you start looking down here, and then you will get an arrow. And when an arrow appears, you have to move your gaze, or your eye direction actually, to the box that's indicated by the arrow. So if it's straight up, you have to look at that box. If it's to the left, you have to go to this box. If it's to the right, to that box.
The circle isn't like labeled.
No. I'm just. That's not in. So the only thing that's actually shown is the arrow itself, and I'm just now using those red sort of ellipses to indicate where they have to go. So the red ellipses are not on the screen. Also, this text, when an arrow appears, move your gaze to the indicated box, that's not on the screen. In any case, so what you this is sort of simulating how people would move their eyes. So they would be looking here at the beginning of the trial. An arrow would appear, and they would sort of move their gaze to that top box in this case. So that's what we can track, and we can monitor, and we can give error signals. If you would be a very vicious cognitive scientist, you might give electric shocks if people make mistakes. Some of us do this. But I, for some reason, I can't get this passed at the Human Ethics Committee at Kyushu University. But anyways, so in this study, so basically we give instructions where you have to move your eyes. Koko mite kudasai. And then we are going to do a little trick. Actually, in the time between you're looking at the fixation cross and before this arrow appears, we're going to flash something. And we're going to say, don't look. Don't look at that.
Do you tell them audio? Like, do you tell them, like, do they hear it, or does it show up on the screen?
So we only give instructions at the beginning of the experimental sessions. We just explain how the experiment works. But the entire experiment itself is done in silence. And so we actually give sort of headphones just to prevent any distraction from noise. So this is the total experiment in silence.
So you're saying don't look, and we're
Yes.
assuming that people are focusing on that cross, but
Yes.
what about peripheral vision? I mean, is it just come in even if you aren't looking at it?
Absolutely, and that's what we want to study in this case. So we're going to see how are people going to inhibit, and what is going to be the effect of this inhibition. So I'll try to explain that step by step. Yes. So that's exactly what this whole experiment is about. So we're giving something that they're not supposed to look at, and we're going to analyze how they respond to that. With the explicit task, don't look. And so what we actually do, what we flash up here, will be a word in the box. So you can already see we had these boxes here. We can place words in there. So you can briefly flash a word there. That's what we're going to do. So we present a word in a box very briefly, and subjects are instructed to ignore the word. So basically, don't look at this. And this word can appear either to the left or to the right. And we'll have this sequence here. So you have basically, you start with a fixation cross, a word might appear, that disappears again, and then you have the arrow. So this word appears somewhere in between this moment, in this delay between beginning and when you actually have to make the eye movement, and that's the thing you have to ignore. So we call that an irrelevant onset cue. Now, the trick here, and it's the second element of don't look, is that we use neutral words and taboo words. Anybody understand Dutch here?
I only know one of those words.
But some already say. Yes.
So is it orgy or is it incest?
We flip everything in Dutch. So teef, hoer, orgie, incest, piemel, neuken, beffen, pijpen. It's really one of my goals in doing this research was to get this list published in an academic journal.
You're going to have to bleep these out.
No. This is as a list
This
in
is
the journal. This is academic. We don't, I mean, at least up until that time, didn't censor that. So we have neutral words, such as a word like, it says circle, you can see scissors, branches, parade, and stuff like that. And we have taboo words.
What's the third one on the neutral? Stoop?
This one, the neutral, stoop, stoop, sidewalk.
Wow, we use the same term in New York.
Oh, really?
Yeah.
Yeah, but that's, it used to be New Amsterdam.
That's the Dutch connection.
It's exactly.
Yeah.
It's our backyard.
Was this experiment done to Dutch speakers, like fluent Dutch speakers?
Yes. So this experiment, I should say, maybe to give full credentials to my collaborators. I was going to do that later as well. But let's see, go back to this slide. So this paper published in Vision Research, actually a good while ago, more than 10 years ago already. But it was done together with my good friend Jan Theeuwis. It was done while I was still in New Zealand. And it was done by my graduate student, Matthew Weaver. And so this was a New Zealander, a Kiwi, that I sent from New Zealand to Amsterdam. And so he was studying Dutch very vigorously. But basically, the study itself was done in Amsterdam with native speakers of Dutch. And yes, you might ask yourself, are there any taboo words in Amsterdam? But yeah,
Are there?
but there are. We'll show evidence of that.
That hedonistic city.
Anyway, so I'm going to now try to explain why are we doing this study, whatever for, what is the reasoning behind this. And I did a whole bunch of work on this. And the one simple concept of that is active vision. And active vision, I wrote an entire book about it, Active Boundaries of Vision. But it is basically against a dominant theory in psychology. A dominant theory in psychology, which I will call sort of old school, sort of input-output model of vision, is basically saying how vision works is you have information somehow that hits your eyeball, and from there it goes to the brain, and it gets interpreted and will lead to a response. And so it has basically a linear structure, input-output structure. And eye movements, according to this view, are ballistic. And so when you make an eye movement, this is very much a motor command. And so it's your brain telling you, look there. And so you're just executing this. And so executing this is simple, basically doing what you're told and mechanically doing what you're told. And that's why they call it ballistic. The comparison is like shooting a rocket or a bullet. So once you've launched it, it wouldn't change anymore. And so, it just goes, it's output. Now, this, I think, is total crap. And actually, when I started studying eye movements, I very much realized from the beginning that eye movements are something funny. Because are they input or are they output? And they are output because they're movements, but they're also input because they're aimed at getting visual information. And so you can't classify them rigorously in this old model. And it had to be wrong. And so it became almost my early career sort of goal to prove that that was wrong. we're going to get on to our last vampire movement. So when I say against ballistic movements, then I have this image of Kong riding the hydrogen bomb in Dr. Strangelove. And so, who made this movie? I'm just realizing the name is up there. Yes. Anybody? Yeah, that's no. So let's. I have to update the question a little bit. I was going to ask who made it, but it's up there, so it's not fair. So what is this movie about? What kind of movie is this? You already got one. I'll give the minus guy another chance if he knows about the movie.
I haven't seen it.
You haven't seen it? You should. You really should.
Yeah.
It's a great movie.
I saw it a long time ago. It kind of
Okay.
feels like the inevitable march towards destruction.
Yeah, that's true. That's
you
true.
already have
But
a
you
vampire.
you already have one. You were gonna say?
Sorry, I guess.
It's about a guy riding a nuclear bomb.
Well, that's true. That's good enough to get on.
I was gonna say it feels like the inevitable march towards destruction. Like-
Exactly, but that's just repeating what you was said here. So I'm
Oh, I forgot to worry.
yeah. Oh well, that's really good.
That's the whole.
But you're an organizer, so you'll get a bag at another case.
Yeah, I'll give it.
So yeah. So this is really it's a satire about the Cold War. It was made in 1964. It was actually an idea that was sort of talked about between Thomas Schelling, who later won a Nobel Prize in economics for behavioral game theory, and Stanley Kubrick, and the writer of Red Alert, which was the novel that sort of inspired this movie.
Great movie.
Yeah, absolutely great movie. It's one of the best satires ever, and Peter Sellers is absolutely crazy in this movie. So, and it's exactly about this mutually assured destruction, and it gives a satire story about that. But what I like is this unforgettable image of Kong riding the hydrogen bomb that gets dropped, and he's really sort of trying to steer it as wood, and it's sort of sort of whooping the whole time.
American shot in
So yes. Anyway, so our hypotheses and what we were setting out to do with this study, with this don't look study, which had two aspects of don't look. It had, the words that you were not supposed to look at, but then within these words, there were taboo words, which culturally speaking, we are not, usually supposed to look at. So our hypothesis was that we would be able to prove in very sophisticated ways that we have active vision here. And so the input, output の考え方は本当の間違いというのを、これで示すことできると思ってました。And so we were trying to think eye movement is a complex system. It's a complex system, which means it's non-linear. You can't simply go linearly from input to output. You have a mess in between. It's non-linear dynamics with deep interaction between brain modules, which means that once an eye movement is launched, you might have cognition happening, which can sort of influence that eye movement on the go as it is flying. It's as if Kong is riding your eye movement.
So modules means like parts of the brain?
Yes, yeah. So when you talk about the brain, it's well accepted that we have a modular organization of the brain. We have prefrontal cortex, we have occipital cortex, we have different parts of the brain that are dedicated to doing different things. And so these different things talk to each other. And so when you recognize something, that would be signaled to another part of the brain and might influence on the go what is happening there. That's what we were setting out to prove. So we were basically in a very, the input-output models would say when we launch an eye movement, nothing will ever interfere with that eye movement. It will just be, if you go straight up, it will just go straight up. Our hypothesis was that we will see influence of the thing that should be ignored. We can track evidence of this influence in the eye trajectory itself. And so I want to show that. And to put it in a straightforward question is, will the eye movement trajectory be influenced by the words that we're flashing up? So these words are supposed to be ignored. The short answer is yes, big time. This is the data as it was shown in the paper, but I'm going to try to explain it in an easy way with the main data. So we saw the first observation is if there is a word there and you're making an eye movement to the box straight up, we see that the trajectory actually bends a bit away from the word.
Just to review, this is like the word shows up, it disappears, and then the arrow points to like.
Yes,
way,
yes,
right?
exactly. So to go back to yeah. So the word itself is really flashed for only 100 milliseconds. So a tenth of a second. So a tenth of a second is very brief, but it is long enough to process the word. And so even if you flash a word for only 17 milliseconds as like one sort of screen cycle on a 60 hertz monitor would already be enough to be able to see that word if it's not basically. So if you were trying to look at it, you would definitely be able to recognize it. So if you would say, if you do a different task and you would say, read the word, and you'd be presented with it for 100 milliseconds, most people can read it. Yes.
So this is kind of fundamentally different from the subliminal
Subliminal
sort
yes,
of thing.
absolutely. So this is supraliminal. Supraliminal. So subliminal is a technical word. Subliminal means we can find evidence of implicit processing even though people don't realize that they have seen it. And so subliminal tends to happen if you have less than 50 milliseconds presentation in a complex environment. And so if things are flashing all over the place and you're presented very briefly with something in between, many people will not be able to remember that there was something there. But if you measure eye movement or biometrics, you can find physiological evidence that they are aroused by it, so that they're influenced by it. So if you sort of sequence a shocking image in like a music video or so, then you would be affected by that image. You might find physiological evidence that you've processed that, but people would usually not be able to say what they saw. They might feel something, but they don't know what they saw, and that's the subliminal. But here it's supraliminal, so it's definitely something that people could see and recognize. In the data, we find, so the first observation is this word. After it disappears and then the eye movement starts, we see that there's this bend away from that word. And so the eye movement bends away from the word that has to be ignored. So it's as if this don't look is actually literally putting a damp on that location. And so that means that the eye movement will go around it. I could do a very complex explanation on why that's the case. And it's partly in a part of the brain called the superior colliculus, which is the part of the brain that does the metric for the eye movement. That works by a field sort of calculation. So I'm losing the audience right here. Anyway, so it's like you put a stop there, and because of this stop, you just go around. The second observation is that if this word is presented to the right, migi datara, this bend is stronger. So the eye movement bends even more if the word appears to the right. And so that's a language effect. And the reason for this is that words to the right, they go straight to the left brain half, which is the language brain half. And words that are presented to the left go to the right, which is not the brain that does word. So we see, I'll get to you right away. So the point is, if a word appears in the side of the screen that goes straight to your language brain, then you're distracted more by that word. And so you have to do a heavier inhibition. So when you say, don't look here, but here there is more distraction, you push back harder, which means you bend further around.
Has anybody repeated this study with cultures who read right to left?
very good question. And so it has really to do with laterality. So the idea that we have laterality, oops, I'm not sure what's happening here. So the idea that we have laterality, the specialization that one brain does language and the other does something else, that is universal. All people have that. But the relationship between which language goes where is stronger for right-handed writing cultures and from left to right writing cultures than, for instance, people who have Hebrew as their native language and who write from right to left and sometimes are more encouraged to write with their left hand. And so you see that this handedness is a bit influenced by that. But this is, I'd say, true for 80% of the people. So I'm looking for commonalities, and I would say this is what happens for most people. So I would say all people have some kind of segregation because it makes sense computationally to distribute tasks. If you do a language in one part and something else, something different, you can do two things at the same time. You can drive while talking. And so that optimality is universal. But whether the language goes to the left is not as hardcore universal. It's the tendency that happens for most, same as most people have their heart to the left. Not everybody has. Some people have their heart to the right. But so there is this kind of biological asymmetry that has fed a cultural asymmetry. But yeah, very good question. Are we good? Okay.
I could talk about like the left and right side.
Yeah, but we can have some more questions. Yes.
Distinct, but anyway, please.
Sure. Okay.
Because I'm not.
We could do. Thanks for this. I don't feel pressure anymore. So, I want to go to the observation 3. So if we go back, we had 2 observations up to now. First one, we have the bend, which is already proof of active vision. It already says there is an influence. So the input-output model, strike one. We have them down. Here, the second observation is it bends more if the word is to the right, which is a language effect. This is second evidence of active vision. Strike 2. We have actually, and I think this is really the piece of the puzzle, a third evidence, which is that if the word, I'm putting the F word here, just for reference, I showed you the words that I actually used. If you have F-like words there, then the eye movement bends even more away from the word. So you get a stronger inhibition, which in this case is, I'll get to you right away. This is a second order effect. It happens after language processing, and it's after language processing that you get an arousal, an emotional processing. And so this difference actually between a neutral word and a taboo word is equally strong to the left and to the right. And so that also suggests that this is not in the language half that it happens, it's in the emotional processing that it happens. So, yeah.
Okay, so before you said that this is superliminal, it's not subliminal, but I'm wondering, so like if a person detected that at the subliminal stage, is that enough for them to direct their eye movement, or are they having to recognize that it is that word?
Yeah,
so do they know that it's that word and that's why they're doing it, or do they not know and they're doing it anyway?
So I did a bit of a shortcut on your answer, in part because we can't say trial by trial whether it was effectively processed consciously or not. And so we asked the subjects afterward, did you see the words and what kind of words they were? Most subjects were able to say, yes, we saw words, and they couldn't remember all the words they saw, but they knew that there were some taboo words and that there were some neutral words. So, but on a trial by trial basis, so from that perspective, I would say it is at the supraliminal level. So it means subjects were able to process this consciously. But whether they actually did in each case is a different question. And so when you say, usually the category between subliminal and supraliminal in psychology is done, we require a lot of evidence to prove that something is subliminal. And so when I say this is supraliminal, I'm basically signaling that I don't want to get into that debate and that I'm admitting that it could be conscious. But whether it's actually conscious, I'm not going to say. Maybe I want to say that, but a psychologist would want really strong evidence to prove that this is subconscious. And so when I say this is conscious, then they say, okay, you're off the hook. But if I say this is subconscious, then they will start saying, you know, how did you check that this not entered consciousness? And then I would be in trouble because I don't have evidence for that.
I mean, just intuitively, I find it very interesting because a word like this, it brings a strong reaction. It makes me think about how you cannot be listening to anything people say around you, but then they say your name, and you hear that one person 15 feet away who said your name. That's the one thing that makes you
absolutely, yes.
Or like someone.
But see, this kind of in the literature that's called a cocktail party effect, and what you have happening there is that you have automatic recognition of your name, but this name will then enter your consciousness, and so people would still call this a supraliminal effect in this case, because you're aware that your name is being called.
I wasn't really aware of that difference there, so thank
you. Great.
Yeah,
okay, excellent. So our hypotheses of active vision totally vindicated. So I think this study really nails it. And I would say our efforts of not looking prove that we've seen it. And so the fact that we are going out of the way, literally out of the way, to avoid that is clear evidence that we processed it. So why can't we avoid looking even if we try not to? So here's where I go to evolutionary psychology element. So I've taken the phenomenology approach up to now, just describing and analyzing behavior, staying away from the why or what for question. But ultimately, we do want to get that. And here I want to go more to literary theory, because cognitive scientists really don't want to go to those stories. They will call them just so stories, and they will just look down on evolutionary psychologists. They're not scientists, they're storytellers. That's what they would say. But I like stories, and I like storytelling. And I particularly like this work by Maurice Blanchot. It's a literary theorist. He's an essay writer. He wrote a book called The Space of Literature, L'espace littéraire. And he opens this book actually with the Orpheus myth. And he says this moment that Orpheus looks back, that is exactly what literature is all about. And he takes that as the sublime moment of literature, because he says the fact that he looks where he's not supposed to, that's inspiration. That's where you have discovery. That's where you have mental and cognitive excitement. So he calls that inspiration. It's a very good point. And so that might be a part of it. Other people might say it's what gets the kill for the cat. It's what kills the cat. So curiosity. And so actually some behavioral analysts like D. Berline have talked about that. How he was one of the first people who was against this input-output model of behavioral psychology. And he said the one thing that people cannot explain is curiosity. And why do birds take extreme risks that don't make sense from an evolutionary sense to try to find something, curiosity. And so he suggested that curiosity is an intrinsic mechanism for learning, and that is how we can combine pleasure and learning. So curiosity killed the cat is the proverb, but you might also say curiosity made a genius out of Curious George. But anyways, that's my talk. I have a little bit of further promotional stuff. So if you want to follow what's happening in the lab, or you want to take part in the vampire thing, then get in touch with me, and I'm very happy to collaborate with anyone.
Oh, wait, that's for sure.
That's my talk.
Okay. All right. So what? Okay.
How long did I talk? I do. I told you.
You've spoken for like two people's worth.
Yeah. So that's my
Then
excuse.
perfect. You had three originally planned.
Yeah,
so.
that's right. I hope Takeru is okay with that. So. Okay.
He's still there.
Well, I guess like do we have a couple of outlying questions? Or, okay, James, go ahead.
You guys need to go, right?
Sorry, I just had a question. It's okay. Yeah.
These guys are off to another party.
Oh, really? You're not gonna stay for let the young kids go out.
Alright. Question about peripheral vision.
Okay.
Playing a role in that.
Sure.
Different people have different, I don't know, like inherent abilities for peripheral vision.
That's true.
Is that something that gets tested, like, before they even go into the experiment? Like, how much peripheral vision does this person may or may not have?
Yeah.
Something like that.
Yeah, we didn't test for that at all.
Okay.
And so we have in psychology or sort of more like physiology, when you get into oculomotor physiology, then we actually have, strictly speaking, 3 regions of what we call retinal eccentricity. So retinal eccentricity, retinal for retina, so the back of the eye, and eccentricity for how far you're away. So the center of vision is called the fovea.
Yeah.
And so foveal vision is in the center of the back of the eye, is where we have our cones and our rich vision. So that's where we can see sharply.
Yeah.
Now, around that we have what we call parafoveal vision. And so parafoveal vision is still reasonably good. And I would say parafoveal means this is the part that goes a bit outside. Everybody can basically see that. And then we have peripheral vision that goes further and further out. And so this experiment, literally speaking, was done in parafoveal vision.
Oh, okay.
And so
it
our,
stays within that range.
Yes,
Okay,
yeah,
I
exactly.
see, I
So
see.
everybody can normally see this. So we do test whether people have normal or corrected to normal vision. So,
Okay.
but yeah.
So that's the control, is that they stay like within
But
the range.
if you would do a really sort of a very close sort of peripheral vision kind of experiment, then you would have to check exactly like how far out people can notice things.
Okay.
Yeah.
Cool.
So if you do like cockpit pilot kind of visual psychophysics experiments, then you would have to test that.
I see. Cool. Thanks.
I asked you this previously, and I want to ask it again. But
Sure.
Did obviously when the right side is much more pronounced,
Yes.
we're trying to avoid. Wait, we're trying to avoid.
The left side, right?
Sorry, yeah. Sorry. But there's obviously a discrepancy. Yeah. I'm not one of your students yet. Well, I'm one of your employees, so that's going to be worse. Anyway, is there a difference between like right-handed and left-handed? Yeah. Good teacher here.
Yes, sir.
Or just grab anything?
Yeah.
Yeah.
I'll ask the questions either way. Like, how about right-handed, left-handedness? It seems like if you're
Language centers.
yeah, but like that's
It's all good.
the people who are left-handed, who are more left inclined.
Okay. So yeah,
The people
go
who
ahead
are
with your
left
question.
inclined, left-handed, left-footed, right-handed, right-footed.
Handedness. Okay.
Yeah,
Yes.
is there a difference?
Thank you.
Did you test for that? Is there a
Yeah,
difference?
so there would definitely be a difference for that. And I'll say cheers.
Yeah.
Thank you. I got Hulhaarden. Yes. And so the answer is yes, there probably would be. And so we did control for that, which means that we only worked with right-handed people. And so this is very common in cognitive science, in cognitive neuroscience experiment, to avoid that factor unless we are specifically interested in that. So if you would be interested in how handedness affects this interaction, then we should do that. But we wanted not to get there, that was too complex, so we decided to work only with right-handed people. Yes.
So, like, sort of learning stuff, that idea, visual
Sure.
learning stuff, is did you take into account that during this study?
Yeah, so that's a really very good question. So I would say we literally only took into account what I've shown. And we tried to control all other factors that could have an impact. And the way we control that, there's two things. So one thing is to try to keep everything the same for everybody. And so we do that by having only right-handed people. We do that by having always the same experimenter, always the same room, always roughly the same kind of environment. So keep things the same for everybody as much as possible in the experimental condition. And the second aspect is to randomize. And the randomize is to treat as a random factor anything else. And so we didn't check whether people had coffee in the morning. We didn't check, whether they had a lot of training in, for instance, visual inspection tasks, whatever job they might have. And so if you think about that, naturally, if you compare across people, we would have different habits, different eating habits, drinking habits, sleeping habits. We had to have different habits in terms of visual behavior. All of these things can have an impact on how we do our visual behavior.
Right.
And some things can help, or some things can create noise, but we treat all of those aspects as something that we're not interested in this study, and we replicate the data from enough subjects, so we get 40 subjects to do this, with the notion that any such factors are sort of randomized out in our data.
Like a rough balance.
Exactly, just sampling, and so thinking that our sample would be robust against such noise. We call that noise, but
Okay. Hold your
You
questions.
can't tell like one definitive answer. Do you think it has an effect in your opinion?
yeah, so here we can't say. But so if you would do, just as an example, if you would do a this becomes a psychopharmacological experiment. So if you give people a triple espresso right before the experiment, it's going to affect their eye movement, and it's going to affect the quality of this execution. And so one prediction is that you might have a paradoxical effect. The worse you get at motor execution, the better chance there is for cognition to have an impact. And so the messier it would get. That's one prediction. On the other hand, you would say if you have people who are very good at learning visual processing, if you have a video gamer who is very good at visual motor control, then you might say that person is probably better at reading out the semantic information. And that person is probably going to have less influence of this kind of flashing of words. So in general, the better you get at perceptual motor skills, the less you're going to be affected by the cognition.
Okay.
Yeah.
That makes.
But that's a hypothesis. So we would have to do an experiment to prove that.
I don't want to stop you.
Okay.
I don't want to stop you there, but I'm going to have to stop you there. We're certainly over time, and we're at a good point to close the meeting up. Yeah, we'll be here for a little while longer. So please give another round of applause to.